Hi, can you hear me?
Yes, sir.
Okay. Okay, we'll start. I don't know if anybody else is going to join. So, we discussed last time that we can try to do one shortlist set of problems from one shortlist per week. And I mean, honestly, I am falling behind. Probably you have already completed the what we had thought about, that we'll finish 4 problems of every topic. So I myself will, and most likely this will keep happening, that I will lag behind you because I will not be able to spend the same amount of time as you to solve the problems. But I'll still be available to give you some guideline about how you can try to organize your study. And just one thing I wanted to show you, that as and how I'm doing the problems, how I'm organizing the notes, so that it is whatever information I'm gathering right now is available as reference for future. So just wanted to show you that document, and not necessarily that this is the only way to do it. You can have your own way of representing, but I think this is a useful way of arranging the information that you're studying, because as you go ahead, revision becomes a very important aspect, that you cannot possibly go into the details of every problem that you have solved in the past. So you need some quick way to look at the same data quickly, and revise the ideas, techniques. So this is how I've started to organize things, that basically at the top level, I've tried to create some kind of hierarchy of what are the problem solving strategies that are being applied. And I mean, there are some sort of keywords here which I have chosen based on my understanding, and sort of categorized every problem that I come across in one of these buckets, that whether it's a configuration problem, transformation problem, or what are the basic ideas being used here. So, and this can get as detailed as you want, or it can remain at the top level. So the flexibility is up to us. But
Like
I mean,
I also have made something like this.
yeah, that's good actually. Then I
I'm
will.
not really, I'm a shortlist, but like in
Okay.
general.
Yeah, sure, sure. I mean,
Currently,
actually,
it's like around 20 pages. Something.
oh, yeah, that's good actually. So, I mean, it doesn't have to be only shortlist. Any problems or that you have. I mean, the focus has to be, on the one hand, it has to capture as much information as possible, but in as concise a manner, so that revision time. I mean, if you have 20 pages right now, if you can figure out a way to boil down the essence to 10 pages, that will make your revision faster. So, I mean, it's finally up to each of us, that how much detail you want your own sort of memory toolkit if you want. So this is one way of organizing the information. Along with that, I'm also doing a couple of other things with every problem which I solve. So of course, we look at our own solution, we look at official solution, but I think it's really useful to break down the problems into what I call the milestones. So I mean, this is something I keep on saying at times in lecture, that the difference between Olympiads at various levels is not the difficulty of the theory, but how many intermediate sort of building blocks you have to guess to get to the final solution. So if you can break down a problem into these 2 or 3 intermediate steps, that if you reach this, then you can proceed to the next step. So each individual bullet list, for example, in each of these problems is like a one objective which is easily within your reach, so that you can go from one milestone to the next one. And then in actual exam, the challenge is more of guessing these milestones. I know, generally speaking, if you guess these intermediate conjectures correctly, then you can connect the dots and finish the problem. So I think it will be very useful to create this kind of a and you see, it's much easier to read 3 points than to read the full solution, because scanning the whole solution, it's very hard to pinpoint which was the most important idea which led to the solution, right? So I mean, if you just distill that in some way like this, it may be easier to revisit the problem the next time if you come across it. So that is one thing you can do. And then the third thing, which is very important, which I again keep on emphasizing, is constructing new problems. So, the first was strategies, the next is milestones, and third is variants. So variants is that take the same idea, try to create your own problem based on the same thing. So, for example, the first question which had the telescopic sum, which led to the inequality, I tried to modify that and come up with one problem. And I have a few other variants also, but I decided not to share with those with you, because some of them are actually quite good problems which we could put in an exam or somewhere. So but yeah, I mean, the idea is you can try to do something like this on your own. So I mean, keep expanding your time along these lines. Of course, I mean, I don't want to say that spend too much time doing this. I mean, it shouldn't be the case. You're spending a lot of time organizing the revision material and less time on actually problem solving, but try to maintain a good balance between these things. And see, I mean, these are just some ideas which I'm going to continue to expand these notes at my own speed, maybe not at the same speed as you, but eventually it should become a good reference for future studies. Okay. So that is one.
What was the second part? Strategies, what and variants?
Milestones. And basically any name you want to use. Basically breaking down the problem into the 3 or 4 intermediate steps, which will lead to the final solution.
Yes, sir.
And in fact, almost pretty much these bullet points are how, if somebody is designing a marking scheme for this question, this is pretty much how they may also do it. That somebody will view, if like A1 is a 7-mark problem, then the reaching the telescopic expression may carry 1 or 2 marks, and the next step, and so on and so forth. So almost you get a blueprint of how the marking scheme might also look for a question like that. So although I will say not necessarily every problem can be broken in this way, because like G2 in particular, honestly, I struggled a bit because it was like pretty much it's just angle chasing, right? I don't know how you can break it down into smaller steps, but still I tried to come up with something. So not necessary that every problem will have the same number of steps. Some might be lesser and some might be more. So that is fine. But I mean, what I want to focus is this sort of thought process, that if you go through every problem, analyzing it along these 3 lenses, that what are the strategies used in this problem, can you connect it to any other problem which had the same strategy, then what are the important steps involved in that problem, and if you were to create your own variation of the problem, how will you do it? And so if you keep on progressing along these lines, I think that will make you a better problem solver. Okay, so with that, if you look at the problems actually, so I mean, last time I think what we did was we went through a bunch of problems, but due to time constraint, we had to sort of rush through the ideas. We didn't really get a chance to go deeper into the solutions. So I thought, let us try something different today, that let us focus on only just 1 or 2 problems, but analyzing them fully, so that we get all the aspects of that problem. So I was thinking of looking at A4 and G3. So these 2 problems, which I have at least spent a good amount of time understanding the solution, and thought that we can discuss them. Particularly, I think G3 is quite instructive because there are several approaches possible for G3, and each of them has some, highlights one aspect of the geometry theory. So that is what I thought we can do today.
Sir,
Yes, go ahead.
for G1, I got a different solution which was not mentioned in other official solutions. Like,
Okay.
it was very, it involves less angle chasing.
Okay. Is it easy to describe? Then you can go ahead and tell me. I'll just draw it on the board. Otherwise, you can ask. Send me the detailed solution later on. But maybe just to.
So like, it is evident from the diagram. If you just draw the diagram, maybe like in the problem.
Okay, then let me just open the problems diagram itself to save some time. Yes, go ahead.
So like, instead of those, M I have defined the same way.
Okay.
No. Yeah, so instead of from I considered a perpendicular to BC.
Okay.
And then then let that intersect AC at K.
Okay.
So the triangles AHM and IKC will be KKIM will be congruent.
Okay.
Then by angle chasing, like simply CH is perpendicular to AB and AB is parallel to GH. So CH is perpendicular to GH. So and triangle CHBG is cyclic.
Okay.
And then just by like simple cyclic quadratic angle changing, I showed that angle IJK is equal to angle IJK will be equal to angle IKJ, and so
Okay.
IK is equal to IJ and IK is equal to H, so IJ is equal to H.
Okay. So I guess the other point which you are constructing is going to be D, right? Just that you are creating D in some different way, or no, it's some completely different point.
So like I don't remember what
No,
D
I
is.
think it's a different points.
They're different points. Okay.
So I think like D is reflection of J in M and his point is reflection of A in M.
Oh, okay, got it. So if you get a point of like K somewhere here between M and D, right? Okay, got it. Okay. Yeah, okay. Yeah, I mean, in general, I think the solution which I didn't follow everything fully, but if I try to boil down the theme of how you approach a problem like this, You want to show that ij is equal to ah and they don't have any vertex in common. So somehow you have to force one vertex in common between two segments of those two lengths. And so the official solution, what they do is they create this point D where HD and AH are equal, and then basically through homotheity around point M or rotational point M, they can connect ID and HD, IG and HD. So something like that, but a slightly different approach which you are using, Arnav, is that instead of completing this parallelogram, you can construct a different parallelogram where you reflect AH. So if I reflect AH in M, I will get a line segment like IK. And then my job is to show that KIJ is an isosceles triangle. So
Yes, sir.
both approaches work. Yeah. And in fact, looking at the problem construction, because you need very noticeably that AH is parallel and equal to BG. So I was wondering whether is there any vectors kind of approach that might work out, but given that there is a lot of angle chasing and cyclic quadrilaterals, so it may not be that straightforward, but just something to keep in mind that, yeah. Okay.
So I have a different solution for G4. Can I show?
G4. Yes, go ahead.
Can I share my screen?
Yeah, yes, go ahead.
You have disabled.
Oh, sorry, let me just try now.
Okay. So I don't think I have the. Wait, do I have the correct labels? Okay, fine.
Yeah,
I've
looks
only
fine.
changed
Yeah.
ABC to BAC or something.
Okay. Yeah. Basically, BC instead of BC, it should have been AC. Okay, that is fine.
Okay. Now, the first thing, like, what I did was like, as P moves along this AB line,
Yeah.
PQM, the angles in PQM are fixed.
Right.
So it like by spiral similarity, this lies on a line.
Right.
And okay, wait. First thing is like
Just one question, Siddharth, where is point T in your diagram?
okay. I'll just wait, that's point T.
Okay.
Le-
Yeah.
At this point, it's on that.
Yeah. Okay.
Okay, N is the midpoint of PQ.
Yes.
So the first thing is like define K as the Humpty point, and the Humpty point is like you take a point K on the median,
Okay.
such that MK times MKA equals MB squared.
Okay.
Now this is important because you can show that this triangle is similar to MQP
I see. Okay.
because angle MBK equals angle BAM equals
Yeah.
angle PQM.
Yes. Okay. Correct.
So this triangle is similar.
Yeah.
And we also have these two midpoints which get related later.
Okay.
Like if you take extremities, then like what you get is that you have a point B dash
This is
on AB
G4, Abhinav. Yeah. Okay. Go ahead.
such that now this triangle we know is similar to this triangle because those two triangles are similar.
Right.
So this angle MB dash A equals angle AMB,
Yes.
and similarly you also construct C dash.
Right.
Now what you do is you kind of like take two locuses for like first locus is for N. The first locus is like as it lies on the circle ABC, it should lie on circle ADE where D and E are midpoints,
Okay,
AB, AC, and also it lies on the line B dash C dash.
right,
So it's either of these intersection points.
right,
And now we can finish the problem like now AB times AB dash equals AM squared.
yeah,
So AD times AB dash, wait, what? Did was somebody saying something?
no, AB dash into AB is AM square, that is correct, after that,
Then AD times AB dash will be AM squared by 2 because D is a midpoint.
D is a mid, okay, fine, yes,
Similarly, AE times AC dash is AM
yeah,
squared by 2.
yeah, correct,
Now we consider the an inversion with radius squared as AM squared by 2.
okay,
It sends these 2 points to each other.
yeah,
So it sends the circle to the line
right,
and vice versa and keeps these 2 points fixed.
yes,
So AF squared will be AM squared by 2.
yes, correct,
And so this length upon this length will be 1 by root 2,
okay,
which implies this length upon this length is root 2. And we are done.
okay, okay. So maybe just one or two things which I didn't fully understand. So we are defining B dash and C dash as the points such that the basically it's like the tangent secant kind of configuration, right? Okay. Where angle at B dash is the same at the angle at vertex M in the left triangle and same in the right.
Like AM squared equals AB times AB dash.
Right. Okay. Okay. So basically we are creating AM to be the common tangent of the two triangles on both sides. So BB dash M and CC dash M. They will both have AM as the common tangent in some sense. Yeah, okay, okay.
And we are
Usually
utilizing the
show
fact that this triangle is similar to this triangle to get the ratio
Yeah,
angles.
correct. Yeah, correct. And basically, I mean, as the shape of triangle MPQ remains fixed, so the N itself is going to move on a straight line. Yeah, okay.
Sir, how did we show that n lies on a straight line?
So what we do is like if now you know that this is a like the angles in this triangle are fixed. So like
Basically, there will be a spiral homothency with known constants, which will take P into N, right? Around center capital N. So angle PMN is known and the ratio PM upon NM is also known. So whatever is the locus of P, that whole will get transformed into the locus of N. Yeah, so this angle alpha is constant and the ratio PM upon NM is also constant. So therefore, since P lies on a straight line, so N will also lie on a straight line.
Yes, sir.
Okay.
and here PMN is similar to triangle KMC.
Yeah, KMC. Okay. Sorry, why is that?
Because we have that KBC is similar to MQP.
Okay. Okay.
And you take the midpoints.
Yeah. Correct. Okay.
And we know that like why B dash comes is because N and Q dash will be similar to A B dash M.
Right.
Yeah.
Okay.
Because like M and Q is angle M and Q is angle AMB equals angle MB dash A.
The fixed line for n is b dash c dash. You prove that by taking the extremes, right?
Yes. Like Q goes to A.
Yeah, and
When Q is A,
Yeah.
we get that.
yeah, thanks.
And we utilize that these two are similar to locate those points.
Yeah.
Yeah. Either that or alternately, if you could have just shown that Basically, triangle M B dash C dash lies in the same family. Then, like at some point, it will get taken by point N, right?
I could also show this by some angle chasing, but that's not really the motivation here.
Right, right, yeah. Okay. Yeah, this is a good solution. Actually, I mean, I think it does a good job of illustrating one important idea in solving geometric problems is that typically you are given the problem statement as if it's a static diagram, but doesn't have to be that way. I mean, of course, you don't have the luxury of GeoGebra, but try to imagine what can be sort of considered invariants, that if you move one particular point or along the particular locus, how does the whole diagram transform? And if you get that kind of intuition and understand which aspects are invariant and which are dependent on each other, that can inspire you to look at the right approach.
And this solution also like generalizes, like if suppose if instead of t you take some fixed ratio on this line, then you can still get it. Like here we took AT by AN,
Right.
where n is the midpoint of PQ as 2. If we replaced it by some other constant, say A, then AM by AN will be, I think, root A or something.
I see. Okay. So, I mean, the rest of the problem remains the same, that T is going to lie on the circumcircle of ABC.
Yeah.
Yeah. Okay.
We just change the ratio of
Right.
AN by AT.
Okay. Okay. Yeah, I guess we can probably
Only
derive some
this
connection.
circle like shrinks and
Yeah, correct,
expands.
correct, yeah, correct. It will not necessarily be the circle with ratio half, but some other ratio came in. Yeah, that's interesting. Okay. Any other comments about this problem? G4.
I have a differentiation for G8, but I'll send that in the group. So
Yeah, sure. Yeah, and maybe I think when many of us have not really got the chance to look at the other problems. Yeah, maybe we'll take a look after we get a chance to attempt it. Okay, thanks. So then maybe I'll get back to problem G3 for now, because as I said that there are some aspects in the solutions of G3 which are quite interesting, and want to motivate transformation based approach to thinking about a problem like G3 and how we can get started along those lines. So again, just to this also gives the opportunity to indicate the point that there are multiple ways to draw the same diagram. Doesn't have to be the same starting point every time. So the problem goes something like this, that we have a point P such that these lengths are given to be equal, and then you consider the circle or rather a circumcircle, a semicircle with diameter VP, and that on that, if we consider, I think this should be called D. This is point P, and then from point P, when we draw a tangent to this circumcircle again, semicircle rather. Okay, then we want to prove that CQ AD also meet on the same circumcircle W. Okay, and so that is what we have to prove. Okay, and so instead of drawing the whole this thing, I can just draw this as a circum 90-degree angle. That is also sufficient. And so clearly the first thing that we realize that whatever that point of intersection be, so if we extend AD, for example, and let it meet this circle once again at some point T, okay, then this is a 90-degree angle. Okay, so in other words, and given that VTA is 90 degrees, so VTA is 90 degrees implies that in fact the point T also lies on the circumcircle of triangle ABC. So in other words, the circumcircle of ABC will contain this point T as well as this point. So in fact, we can sort of construct the problem the other way around, that let us extend AD, let it meet the circumcircle at point T. And then we have to show that TQC are collinear. So to do that, TQC are collinear. Okay. And if we continue to expand along these lines, that what is equivalent statement of showing that TQC are collinear? So if you just look at some basic angle chasing, and basically you have two sets of cyclic quadrilaterals here. One is the semicircle with diameter BD, because of which we can chase this angle. So this angle QTD, you will see that can be chased and be equal to QBD. Okay. And if what we want to show is really true, that TQC are collinear, then what we expect is that this angle should also be equal to angle CTD. Okay. But CTD itself can be changed in the larger circle and it's equal to CBA. Right. And so you'll see that if effectively what we want to show is that, I mean, this is
QBC is DBA.
yeah, exactly. QBD is the same as CBA. Okay. And given that these are right angle triangles, so basically what we are really wanting to show is that triangle QBD and triangle CBA are similar. And when they are similar that way with one vertex common, so effectively what we want to show is that there is a homotheity between, so to prove that triangle QBD and triangle CBA are related by a homotheity or other spiral homotheity in this case. So what that homotheity will take point D into point A and point Q into point C. Okay. So at this point, it is either like some kind of computational approach that you can compute the ratios and the angles to show that indeed these two triangles are similar, and that is how you can finish the problem. Or there are few more elementary, like less computational ways to do it also. But this way of simplifying the problem in a way where try to you see that in this formulation now we don't no longer care about the point D anymore. So point D is kind of eliminated from our consideration. So in this way, how you can simplify the given problem by reducing the number of independent variables or other derived variables also. You can continue to change along these lines, that how you can further simplify this problem, make it even simpler. For example, there is one way to get rid of point A also. I mean, why do we require point A in this diagram? What is the role of point A in defining this diagram? If you think about it carefully, it's just to locate the point D such that these lengths are equal. Okay. But if you think about it, the same can be achieved if instead of point A, if I consider its reflection A dash over here. Okay. So basically, I'm looking at CH, which is parallel to AD dash. Okay. So I can sort of hide the bottom half of the diagram completely. So I could, for example, forget about this part and just look at this part. Okay. So then these are some ways in which you can transform the whole diagram and see if that simplifies things for you. Okay. So I don't know if anybody has proceeded along these lines to finish the problem.
Sir,
Yeah, I
you
did
use that
this.
PQ?
I think the same.
Yes, sir.
Okay. Okay.
Where did we use that PQ standard to the circle?
No, we have not used it so far, but we will have to use it now. So yeah.
Okay, sir.
Okay, so maybe Aditya Siddharth, can you explain if your solution is exactly this way or any other approach that you have taken?
No, I think you'll do the same thing.
Okay,
Uh, I didn't use computation to prove like they're similar. Like
I mean, like this ratio chasing.
yeah, correct. So
Uh,
I think we'll get a bunch of more similar triangles in this diagram. So let me see. So, No, I think I need to work out the details offline, but anyway, I'll do it. But at least I think this approach is on the right track, so we can continue with that. Okay. Along with this, I think there are a couple of other solutions which also I found from the official shortlist, which might be worth taking a look at. So, for example, I think there's one solution which is there an inversion based solution? I don't know. Oh, no, not that, not inversion. Sorry. I think because we have one single large semicircle in which we have a lot of common chords and things like that. So I think there is one solution which uses Pascal's theorem. Whenever you have number of concyclic points and you can cross join them in number of ways, so you get collinearities using Pascal's theorem. So that I think there is one solution using that. But again, I would urge you that whatever solutions you are attempting, try to see how you can distill the information that you're getting from the solutions into something like this toolkit which I shared with you. So boil it down to the most important points in each case. Okay, I think that's. I also wanted to talk about A3, but or A4, but actually I'm not well prepared for that, so I'll need some time to understand the official solution completely. I think we can do that next time. But in the meanwhile, I mean, don't let me slow you down. If whatever speed that you're continuing to proceed with the problems, keep doing that. Wherever you get stuck, you take each other's help. Even outside of these weekly sessions, if you want each other's help, you can just post a message on WhatsApp that I need help on this question, and somebody will reply with a hint. So continue to stay in touch with each other for that. Yeah, I think Siddharth, you mentioned about G8. You have some alternate solution. For anybody else who
Yeah.
has alternate solutions, please keep posting those to other WhatsApp group. So we'll keep on gathering the data that. And also maybe one more suggestion, as Siddharth, you said that you already have a toolkit which you have prepared, and maybe other students may have also started with the same thing. So I mean, you may like to show your toolkit to each other so that to give an inspiration about how you can organize things. But I think most important instruction is that if anybody of you is looking at other people's toolkit, don't just copy it down as it is into your notebook. Primarily because it will not help you. I mean, unless you have designed it in your own way, the way you think about problems. I mean, you are going to be the best person to structure it properly. So maybe look at each other's toolkits if you want for some inspiration, but you have to put in the hard work yourself to design the toolkit the way you want. Okay, so I think I was hoping to complete everything about this shortlist today, but I don't think I'm ready to do that. So maybe need some more time for that. So let's meet again on Sunday. Hopefully we'll finish the remaining problems of this shortlist on Sunday. Like again, not all the problems, not the harder ones, but A1 to A4, G1 to G4. So all those 16 problems will finish, and then after that we'll start with the weekly cadence of 4 days plus 3 days. So first 4 days, that is Sunday, Monday, Tuesday, Wednesday, you try the problems without taking anybody's help. And then from Thursday onwards, 3 days, you can refer to the solutions and things like that. Okay, anything else that anybody wants to add? And also, by the way, I guess everybody in the group right now is in Pune, and are you comfortable to meet in person?
Yes.
Yes, sir.
Yeah, I think timing is the only difficulty, because I mean, considering I don't know what common time will be available for everybody, I'll check on the group. If we can find some suitable time to meet in person, we'll do that. Anyways, I mean, honestly, by next Sunday, I myself are going to start traveling, so I will not be available. But I'll it's for your sake that try to meet each other in person whenever possible and exchange some ideas. Try to do some group solving, things like that. So we'll try to coordinate with Pratishthan to keep a classroom available for you. Okay, I think that's all for today. Thank you. Bye.